Good day, students. Today we are discussing a topic which is latent heat. This one deals with ice block when it's in the fridge at 0 degrees centigrade, melting point 0 degrees centigrade. How is dealt when you bring it out of the fridge and you put it on the table, it melts to 0 degrees centigrade. What I'm trying to say is that when you have an ice block at 0 degrees centigrade, it will melt to liquid form. When you touch it immediately, when it got melted, you bring it out of the fridge at 0 degrees centigrade. That there's no temperature change. 0 degree when it is ice block. When you bring it out of the fridge, turn it to liquid. When you touch it, it will be cold immediately before it starts gaining excess heat. Use ml because there's no change in temperature. Under latent heat, there's no change in temperature. But later on, after gaining some temperature, turn it to water, becoming hot. Now that's water, warm water. That's now we are with theta, change in temperature. Now from here to here, we call it MC, change in temperature. Specific capacity to be introduced by initial. But if you have to look for the total heat supply from the ice block to this particular point, where there's some question like that, it will now be H equal to ML plus MC changing theta. You add them together, we're going to see some question like that. Now, what is latent heat? It is the heat supply unremoved which causes a change of state without a change in temperature. It is supplied or removed which causes a change of state without a change in temperature. Now, what is the latent heat of fusion? When you say something is of fusion, fusion means something that is getting melted. Okay, now is the quantity of heat required to convert a substance from its solid state to its liquid form without a change in temperature. Is the quantity of heat required to convert a substance from its solid state to its liquid form or liquid state without a change in temperature. Now, what is the specific latent heat of fusion? You see that when we are defining this, we didn't mention unit mass. And under specific latent heat of fusion, we use small letter L to represent it. It's the quantity of heat required to convert unit mass of a solid, at the melting point to the liquid form without a change in temperature. Please look at it. Required to convert unit mass, very important, of the solid at the melting point to its liquid form without a change in temperature. Under specific capacity, it requires change in temperature, but under latent or specific latent heat, there's no change in temperature. That's why you now see the unit. When you're writing the formula, it will be H equals to mL. H is the quantity of heat supply, M is the mass of the solid, L is the specific latent heat of fusion. Now, when you make L the subject of the formula, become H over M, which is equal to J per kg. That's joules per kilogram. We use joules per kilogram under specific latent heat. The unit of specific latent heat is joules per kilogram, but the unit of specific heat capacity is joules per kilogram per Kelvin, and the unit of heat capacity or thermal capacity is joules per Kelvin. Please take note. Now let's solve a problem under this. How much heat is required to change 3 kg mass equal to 3 kg of ice at 0 degrees centigrade to water at the same temperature? See, no temperature change. And L, what our L is 336,000. Now what it now is mL is 3 times 336,000. We multiply it 336,000 times 3 times 0,000, that's 80 carry 1, 3 times 9 plus 1 10 0 carry 1 1 0. That's where it as you have 3. We have what do you have first? So this one, taking you have 3. 100,800 joules. That's it. This take note. The specific latent heat efficient of air is 33600 joules per kilogram. Just per kilogram. This question, let's analyze what point of heat we've been able to change 2 kilograms of ice. Let's assume these are our ice. We change it to 10. But before moving to 10, it moved to 0 degree centigrade, and before moving to 10, 2 stages. This latent heat, which is ml, the point of heat is ml, but when there's change in temperature from 0 to another temperature, you have mc changing theta. And that case, point of heat required now will be ml plus mc changing theta. Theta 2 minus theta 1. Okay, now which is what the parameters we have from here. Let's start putting it in. What is M? The mass is 2 kilogram. The capacity. Let's latent heat 3.36 times 10 raised power 5 joules per kilogram. It's joules per kilogram. Now C is 4,200 joules per kilogram per Kelvin. Now, for the first time, there's no temperature change. That's latent, specific latent heat takes place. Now we have 2 times 3.36 times 10 raised power 5 plus what's the mass? Same mass, 2 times this 4,200 times 10 minus 0. 10 minus 0. And you have H to be, when you do your multiplication very well, you have 672,000 plus 84,000. Now, it is 756,000 joules. The unit of it is joules. Estimate the point of heat needed to melt the mass, because 150 grams converted to kilogram have 0.15 kilogram. 0.15 kilogram. That's the mass, and you have the temperature difference. Now, before you understand this question, you have to analyze this with diagram. But let's write all the parameters. Capacity of water plus 4,200 joules per kilogram per Kelvin. Specific heat capacity of ice, that's 2,100 joules per kilogram Kelvin. Now, specific latent heat efficient ice equals 3.36 times 10 to the power 5 joules per kilogram. Good. This one we use L to represent it. Here, for the water, we use C, and for the ice, we use C. We just try to differentiate. When it's still ice, you make use of this, or when it has turned to water, you make use of this. Now, what am I trying to say? These are our ice, very chilled. Ice at minus 10 degrees centigrade at the temperature. Now moves to the same ice. It has reduced. It's no more like this. It's still at 0 degrees centigrade. And we are moving from minus 10 to 15. Minus 10 must come to 0 first. Now from the zero ice is still ice. It's turning to water little by little. Now it now turns to water, but it's still chilled. It's still cold. When you touch it, it's still cold. Now you have 0 degrees centigrade water. Now from there, it now moves to, it starts increasing in temperature. Now move to 15 degrees centigrade. Now in this case, now because there are changes in temperature, despite that it's still ice, but there are changes in temperature, it makes your MC change in theta. And also this one will be still temperature. Latent takes place here, specific takes place here, latent heat. Specific heat capacity takes place here, specific latency takes place here, that's the use of ML. Specific heat capacity takes place here, MC changing theta. Now the quantity of heat required to melt it is MC, M ice, C ice, change in temperature, so that this one is greater than this, change in temperature, plus ML plus M ice, density of ice, and the mass of the ice, but it has turned to water as we use specific capacity of water. So of the water and changing temperature. Now let's put in our value. All the mass of ice 0.15, specific capacity of the ice, specific capacity, use C, change in theta. The ice has 2100 times temperature change 0, start is greater than this, 0 minus, for minus when you are doing temperature, change in temperature. Change in temperature is theta 2 minus theta 1. There is minus before that is there. Oh, there's another minus 10 plus mass of the ice is 0.15 multiplied by the latent heat of fusion of ice 3.36 times 10 raised to the power 5 plus mass of the ice that is melting 0.15 times. Now in this case, that has turned to water. We now make use of specific capacity of water 4200. Now don't forget this, change the temperature 15 minus 0, 15 minus 0. Now you now have 0.15 times 2100 minus and minus plus times 10 plus 0.15 times 3.36 times 10 raised to the power 5 plus 0.15 times 4200 times 15. Now the heat that we have to multiply very well. For this one, you have 3150 plus 50400 plus 9450. When you add them together, you have 63000 joules. That's convert to kilojoules divided by 1000, 3 kilojoules. This is the end of our class. Please subscribe to my channel so that I can get access to the latest video on the next on the YouTube. Have a wonderful day.